So we're facing this scary integral that's involving a square root, which usually hints to the fact that we might have to use trig substitution. But since that's a very complicated, it's an involved method, let's just check quickly if we could do any other type of substitution or technique. Well, we could do it by parts, but that's going to be a clever trick, so let's forget about that. And we couldn't do an easy substitution because this is a power of x squared, while here you have x cubed. If this was just x, then you could do u equals 4 plus x squared, and that would work, but not in this case. So yes, let's do a trigonometric substitution. Now, which one should we use? Well, here we have the sum of squares, so there's only one relation with the sum in our trig relations that we know, which is 1 plus tangent squared equals to secant squared. So that's what we want to use. We're just going to manipulate this expression. I want to see a 1, and then I can have whatever quantity that I need. But the thing is that this should be a 1. So I'm going to factor out of 4. I'll do this preliminary work here, then I will erase it and just copy the end of it. So you factor 4 inside the square root. So it becomes like this. And the square root of the product is the product of the square roots. So 1 becomes square root of 4, that's 2. And then here just whatever is left, which is 1 plus x squared over 4. Now I have this 1 that I wanted, and I need to make sure that this thing becomes tangent squared. So that is going to be my substitution. If I want this to be the square of tangent, then it means that x over 2 has to be equal to tangent theta. So that is going to be my substitution. That is the same as x equals 2 tangent theta. And then, not to forget the differential before doing the substitution. So that's going to be 2 secant squared theta d theta. Now we have all the ingredients. So let's change this integral. So also here I have 1 over 2. I can just take it out of the integral. So 1/2 integral. X cubed becomes 2 tangent theta cubed. So 2 cubed tangent cubed theta. Then here I will have 1 plus tangent squared of theta, which is secant squared. So I'm going to directly write that. And then the dx, which becomes 2 secant squared theta d theta. So you see that if you forget about that, then you don't have this part, and the integral is very different. So that's why it's important to always write this dx, du, dy, or d, whatever you're integrating with respect to, because otherwise you're going to forget it in your substitution. So now, okay, this one and this one we can cancel out. These 2 cubed, okay, it's 8, we can take it out. And then here I have tangent cubed. The square root of secant squared simplifies to secant theta. And here I have secant squared theta. So now I can simplify this secant with this power of 2, and I get down to the integral of tangent cubed times secant theta d theta. This is an integral involving the couple tangent and secant. We should do it by substitution, either in tangent or in secant, depending on whether we can factor out the derivative of tangent or the derivative of secant. Now, the derivative of tangent is secant squared, which is not even here, so that's not going to be the case. The derivative of secant is tangent secant, so we're going to factor that out. Like this. So that should be our du in the substitution, provided that here we have an expression in secant. But that's good because we have tangent squared, and by this relation we can change it into a secant. It's going to be secant squared minus 1. So now I can do u equals secant theta. Du is going to be tangent secant. So that becomes 8 integral u squared minus 1 du. And this just powers, so one-third u cubed minus u, and we're done with the integration part. Now we should go back, retrace all the substitutions that we made, and go back to the original variable x. So first, u is secant, so here I get this expression, so that's in secant theta, and then we have to go back to x by using the original trig substitution that we made. Now in order to do that, here we see secant theta, and we have that x is equal to 2 tangent theta, so you either figure out what secant is by using trigonometric relations, or sometimes people like to draw a triangle and fill that out to help with this substitution. I'm going to review how to do that. So let me get rid of all this and just keep the last part. So this integral is equal to 8 1/3 secant cubed minus secant. We're done with this. So we look at two things for the triangle. Okay, let's first draw the triangle. This is a right triangle, and we're going to call this angle theta, and then we need to fill out the sides. So we need to look at the square root expression in our integral, so it's that one, and the substitution that we made. So this square root will be one of the sides, and since in this case we have the sum of the squares, then it's going to be the hypotenuse. So I already know that, and that also tells me that the other two sides are going to be 2 and x, because here you see the square of those. Now we just don't know whether this one is x or 2. That's where the substitution comes into play, so you can see it from here. Right, you have tangent, which is supposed to be opposite over adjacent. So opposite over adjacent. So this is x, and this is 2. And that's how you fill out the triangle. And now, from this, you need to find what secant theta is. So that's 1 over cosine. Which is going to be this over this. And then you can use that and plug it back in here and go back to your x variable. and that's it.